Welcome to the Computer History Museum and our demonstration of Babbage's Difference Engine number 2. This particular one is Difference Engine number 2, Serial 2. What is this machine and why is it called the Difference Engine? It is essentially 7 stacked up adding machines, and by adding machines I mean literally that, not adding, subtracting, multiplying, dividing, square rooting, natural logarithms, etc. machines. I mean adding. Okay? In the day, you did complex calculations by looking up things like sines, cosines, arctangents, logarithms, etc. in big tables. The tables were computed by people. And the vast majority by number of those people were doing what this machine does. Adding a number to another number, that number to another number, that number to another number, that number, blah, 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 up to the end, to the result, and then starting back again. And you see things moving up and down. Those gears would actually couple them together, adding either the odd columns to the even or the even columns to the odd. It's like a little transmission for each set of number words.
Well, this is the oldest single artifact in the Core Store collection. It's an IBM 083 card sorter. It's not a computer, it doesn't even hook up to a computer, it's purely a standalone device for sorting old punch cards. 1950s technology. Purely mechanical, well, electromechanical. The cards go in here, they're sorted through here, and they're stacked according to the sort criteria in these output hoppers. It's programmed just with switches, knobs and wires. When I say 1950s technology, I mean it. It's inside. We have valves glowing merrily away. No transistors here, just valves and relays. Most remarkably of all, it works. We get a deck of cards and feed them in. Make sure they're carefully stacked. Feed them in here. Put the card weight on top. We set sort on. We'll do the card count too. See, there's a counter here. It's showing all zeros at the moment. Card count on. Hit start. And away they go. All done, except for the last one, which is hang up. What does it say? 93 cards. Very useful if you need to count your cards. I'll take these guys out. I'll run this again for a different demonstration. Very important to keep the cards straight. Try that again. This time I'll open the cover, I'll hold down the safety switch, and you can see all the belts and things whirring around. There's more. That is really old technology. The 083 card.
Feed. Register. Now let's type hello world. starter. Today is a great day. Bye, guys. Now this thing go up and ta-da!
In this video, we're going to have some fun and use this reel-to-reel tape deck right out of the mid-70s to load 8K BASIC into our ALTAIR 8800 through the cassette interface board that's in the computer. Now this tape deck allows us to listen to the audio at the same time that it's being routed to the ALTAIR. We're doing that through the headphone jack here. Got a nice pair of Radio Shack Archer cheap headphones right out of the actually early 70s. It's interesting to listen to the data as the tape boot process loads because you can hear the transitions and things that are going on, and I'll point that out as we go through this. Right, in the ALTAIR I've already put the bootstrap loader for the cassette interface in. That's down at address 0. Alright, so let's go ahead and first we'll examine address octal 400. That is our starting address at the leader detector. Alright, and now we can hit run. At this point we can tell we're in the leader detector code because A8 is still on, and here are the lower bits of the address. This right here is the I/O port for the cassette tape interface being read. Alright, before we hit go on the tape player, I want to tell you some of the things that are going to happen because it happens relatively quick. When we first hit play, we are going to hear steady idle tone. That's just a marking or a 1 state, and we will see this code continue to execute. Then we'll hear a transition to a different tone. This other tone is, this tone we hear, it will be the leader byte itself. It repeats over and over again, so it's going to be a steady but different tone. The second the first leader byte is detected, we'll see this pattern change to just the lower bits. Of course the I/O bits will still stay, but basically A8 will go off. That is when the leader detector has jumped to the bootstrap loader because it's detected a leader byte. There's our idle tone. That's just a marking state of 1s, and we're in the leader detector. Very shortly we'll hear the leader bytes, and you'll see this transition down into the bootstrap loader. Alright, that's the end of the boot process. You saw, I'm going to go ahead and pause this tape.